Okay, selecting subsets of predictors. So this is model building, and the goal is to develop a parsimonious model that is the simplest model possible, okay, that will have high predictive accuracy. So it will be both robust and high predictive ability. And we will look at two different methodology. Well, one is theoretical, so exhaustive search is all possible regressions, and that is not practical because the computation time needed is for an exhaustive search is too much. So the most powerful computer will take like 100 years to finish off. If you have even if you have like 20-25 variables or 100 variables, which is really a toy problem. So exhaustive search is not a feasible approach, but we're going to look at exhaustive approach to understand what it is. So we look at every size and every possible regression between a group of x's and y, okay, and then select the best of each size, and then select one from those best on each size. So that is exhaustive model. Now partial search algorithms, okay, they do not, as the name suggests, it does not go through everything, but then they follow an algorithm, right? So there are three of them: forward selection, backward elimination, and stepwise. So in forward selection, we start out with just the intercept, right? B sub 0. Then we look at all the x's. So we have like 15 x's, for example. We look at each x variable and see what will be the R squared value if you include if you put the x into the model. So you'll try x sub 1, you try x sub 2, try x sub 3, and so on, and select the one that gives you the maximum R squared. So put that in. So once that x is in, now you look at the rest of the x's that are still outside, and now try each one, and then see look for the one that gives you the maximum bump in R squared value. So keep going like that until you have brought in all the variables. So this is forward selection, and then once you have a regression model of each size, so now you'll have a model with just one variable, you have a model with two variables, you have a model with three variables, and so on, and then you select the one that you think is reasonable for your purpose. Now backward elimination does the same process in reverse. So you start out with all the variables in, and then you remove one variable at a time and see which variable gives you the least reduction in R squared, and you throw that out. So now you have a model with one less variable, and then you do the process again. So then you have a model with two less variables, and so on until you get to a model with just one variable. And of course, the forward selection and backward elimination will not give you the same set of models of each size. It will be different. So you can try both of them and then see which model would be best for you. Now stepwise regression combines the forward and backward concept at every step. So first you start out like forward selection. You bring in the best x variable in, okay, and then you bring in the second best variable in. Now once you bring one variable in, now you will try to see whether you can remove any one of these variables that are already in within a particular threshold. So if you set a threshold is usually set up in partial f statistic, or you can set up p-value 5%, for example. If the p-value of any variable that's already in is more than 5%, then you will throw that variable out and then bring in the next best variable. So every step will be a forward selection and a backward elimination. So forward selection will be performed with all the variables that's outside the model, bring it in, okay, and then all the variables that are inside the model and see whether you can throw any one of them out. Okay, if a p-value is greater than 5%, you'll throw that one out. Okay, and you keep going until you reach a point where none of the variables outside cross the threshold of 5% p-value, less than 5%. If it's less than 5%, you will bring it in. But if none of them are less than 5%, and then so you cannot bring any variable in, and all the variables that are already in, all the p-values are less than 5%, so you don't have anything that you can throw out. So at that point you stop. So that is called stepwise regression. So we will look at these methods in SAS.